Yes. It's really a really big honor to have Mark Billinghurst here. He was the person who, one of the big inspirations for me in my augmented reality journey. And I first listened to Mark talk about social augmented reality experiences. I think it was like 2008 at ISMA. And he's actually got a new gesture and speech interface that you can go and try out in the expo hall. So I highly recommend this. And he's from HitLads, came all the way from New Zealand just for us. So thank you, Mark, and let's go.
Great, thanks so much. So it's fantastic to be here. I've been to every AWE, and this is the biggest and best so far by far. What I'm going to talk about today for the next 10 to 15 minutes is hands and speech in space. Many times we see different movies that inspire us about what types of future interfaces there could be, and that's the same for me. And so one of the movies that inspired me was the Iron Man 2 movie. And I guess last night, those who went to the Meta Party heard about how they are being inspired by that as well. So I wanted to show a little bit of a clip from that movie. This is a promo clip from the company that did the visual effects. So you can see he's sitting in his car, seeing some sort of visual projection system happening here. And then he's able to use, in this case, there's an augmented reality overlay of this real city model, and he can use his hand gestures to start pushing around the content and interacting with the content in a very natural and intuitive way. So when I saw this movie, I was kind of inspired about how could we really make this real. Unfortunately, we didn't have the budget that the movie had, so we had to try and do it on a shoestring. But if you really want to make this vision real, then there are different things you'd want to have. Some sort of invisible contact lens display, some sort of way you can use freehand gesture interaction and speech interaction, and some way to capture the real environment so you could be able to overlay virtual content on the real world. So in the HitLab, we've been working on different aspects of that, and what I want to talk about today was being able to use free hands and gesture and speech to interact with AR content. So many of us have seen examples over the last few years of being able to use natural hand interaction. So instead of using wands or other input devices, being able to reach out into the AR content and use your real hands to interact with the models. And we've done that ourselves the last 4 or 5 years. I'll show you a little video of that. We've basically taken Kinect depth sensing, being able to find using the depth and skin information where your hands are. And in this case, we fill your hands with invisible balls, and we use the balls to collide with other virtual objects to create a realistic physics-based simulation model. So let me show you a video of this working. So you can see here, there's the invisible balls, and filling, well, not invisible now, but there's the balls filling the hands, and now he's able to use his natural hands to pick up and move around in this case, a tennis ball. We can actually have other objects interacting with the tennis ball, so picking up a piece of paper, and again, using the depth sensing on that case, and you could use that for occlusion as well. So one of the applications we've used this for is for therapy. So we built a interactive spider phobia application. I'll just turn the volume off there, you don't need the soundtrack. But what you see in this case is some people are very afraid of spiders. It turns out if you can be progressively exposed in the real world, then you can overcome your fear of spiders. So we built a spider simulation that lets a virtual spider crawl all over your hands. And the spider has a little bit of smarts, so when you pick your hand off the table, it kind of sticks to your hand. It also knows objects in the real world, so you can crawl over real objects and the like. And the hope is that by progressively exposing people to this, then eventually they'll be able to hold real tarantulas in their hands, not just virtual tarantulas. So it turns out that gesture-based interaction like that is good for a number of different things. It's very good for realistic direct manipulation, selection and motion, and very rapid expressiveness with your hands. But there are some limitations. It's very hard when building user interfaces to express things like time with gestures, or to interact with large numbers of objects, or to interact with objects that you can't see, or to have delayed actions. How do I set in place an interaction that's not going to happen for 5 or 10 minutes? So in the research in AR and in computer interface in general, people have looked at how you can combine gesture input only with other modalities to help compensate for some of these limitations, and in particular using speech and gesture together. So that's very powerful because they're quite complementary. Speech is very good and basically for expressing quantities and for modal commands, and gesture is very good for selection and manipulation and expressing qualities. So there's been a lot of previous work done on gesture and speech together in desktop interfaces and in immersive VR interfaces, but actually very little being done with augmented reality. So that's where we've started to work in that space as well. One of the first things we did was to look at how people would use a perfect system. So we developed a Wizard of Oz study where we had somebody else who was performing the speech recognition. So we had a real person who was sitting on a computer, listening to what you were saying, pushing buttons on this interface to cause things to happen. Using a system like this, we had a camera-based gesture tracking system and then the real speech recognition. And we had people manipulate virtual objects to change their color and size and position. And we told them that it was all being done with a real speech recognition system, but it was just a person that was at the back end. And we recorded everything. We told them they could use any speech commands they wanted to, any gesture commands they wanted to, and we used the wizard to recognize what we were doing. And what we found was that when people were given the choice, about 64% of the time, 65% of the time, they issued multimodal commands naturally, speech and gesture commands naturally. But in most cases, the speech was very short. So on average, people only issued about 1.25 word phrases, so very short. And most of the gestures were pointing gestures, so 65% of the time. And interesting, most of the time, the gestures were begun before the speech happened. So you'd start pointing at something, and then you'd give a speech command when you'd finished doing your pointing. So based on this, we built a real system that could do that. So and this real system used natural hand tracking. And we used free hands to interact with AR content, so you could recognize simple gestures like pointing, flat hands, and grabbing. And then we had some simple speech input that recognized colors, shapes, and directions. And we combined that together in a multimodal system that would let you manipulate virtual objects. The most important part of the system is the fusion engine. So you can basically take speech recognition, gesture recognition, and then combine them together with the knowledge of the history of the interaction and issue a single command at the other end to your AR system. It was also important to have real hand occlusion, so when you put your virtual hand in the real world, your real hand in the virtual world, the real hand should block out the virtual graphics so that it looks realistic. So we built this little system here where you could point at objects and move them around and give speech commands to change their shape and color. And I did a little user study. So let me show you a video of that working. And this is a bit longer video, so this is going to show the different conditions in the user study. So first of all, here's the experiment set up. There's a camera there with no connect at the time. So this is using a Bumblebee camera. Points pacing down, tracking my hands. I look at the monitor, and then I have to do things like change the color, shape, and position of objects.
Left.
So it turns out using speech to move objects is a real hassle. Going left, 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 down. And then you give a bunch of direction commands, then you give a color like blue or green, it changes the color of the object, and then it changes the shape.
Down.
So that's doing it using speech
Right.
only.
Forward. Green. Cone. Left. Down. Down.
And now with a gesture, you can reach out with your hands and grab objects and move them. So it's very natural. And then to change color, you make a point gesture, and it shoots out a ray from your finger, and it picks the colors or the shapes from the top there, so you can use gestures to pick objects very quickly and move them. And you can see the occlusion there as well, so your real hand blocks out the virtual cues. But when you combine them together, what it means is you can do a gesture, and while you're doing the gesture, you can issue the speech command at the same time. So I can pick an object, I can start moving the object, and I can say red, and the object will change color while I'm moving it, so it makes it a bit more efficient. So you'll see that now. So you can see the top-down view. He picks this ball here, and he says blue, or red, sorry, while he's moving the ball. So the upside of that was that we found that basically in the multimodal case, people were able to perform much faster, and they were also able to they liked the multimodal condition the most. When we asked people which system they would prefer using, 70% of the people said that you'd like to use a multimodal system rather than speech by itself or gesture by itself. We also found a significant difference in commands. So with multimodal interfaces, you could use less gesture and speech commands than you would individually. And just like with the Wizard of Oz study, we found people had sequential input where they'd use gestures first and then speech as well. So the lessons learned from that interface was that, in this case, multimodal interaction was significantly better than gesture alone for AR interfaces. Shorter task time was more efficient. The people felt the input was more natural, easier, and more effective than using speech and gesture only. And actually, they used simultaneous input quite rarely. But a lot more user studies need to be conducted. This is obviously a very simple interface. And in that case, we had a very simple model of the hand, and it was really only a 2D task, moving objects around. So most recently, and what you can see today on the show floor, is 3D gesture tracking. So in this case, we now use the 3-gear systems. So this is software you can get from 3Gear that uses a single Connect or PrimeSense sensor, and it provides full 2-hand tracking. So it gives you the full 3D kinematic model of both hands. So we can take that model and then use that in our AR system to provide richer interaction than we had previously. So in this case, we can use a skeleton-based interaction. So now we can reach into the AR space, and we can use our natural hands to pick up and move objects in full 3D and have a much richer interaction than previously, and with both hands rather than just having one hand pointing and moving. In order to implement this, we had to be able to provide a kind of immersive AR view, so we built an Oculus Rift AR display. So we took the Rift and put a couple of cameras on the front, combined it. We also explored using the soft kinetic software and hardware on the top as well. So let me show you a video of this working. And this is brand new off the press. I just got this video at 1 o'clock yesterday morning. So, and where's the video hiding? Huh, it happened yesterday as well. Oh, that's not good. Sorry, let me try it again. Oh, maybe it got corrupted. Huh. Let me just, one more time, sorry for this. Oh. You're right. Hang on, it might be in my browser, so maybe it'll be. Let's see here. Oh, that is a disaster. Okay, well, you'll have to try it on the show floor. It's a really great demo. I'm sorry about that. So basically what you can do in this case is you can reach out and manipulate objects and grab them and move them and have them be able to have physics so you can interact with them in 3D space. And the way this works is we take the Nimble SDK provided by 3Gears, provide it into a simulation controller and do the gesture recognition, combine it with context-based speech input, and then we have a much richer visual feedback with the Rift. So we have graphic shaders and renderers, and we take the position tracking from natural feature tracking, combine it all together, and show the output in the Rift display with some physics as well. And if the video is working, this is what you would be seeing. So you can reach in with your natural hands and pick up and move objects around. But please go and try it on the show floor. So I'm just about out of time, but the conclusions basically are that most AR experiences need new interaction methods. We can't use traditional keyboard and mouse anymore. So what we've been looking at is how we can provide combined speech and gesture input. And this provides a much more powerful experience than gesture by itself or using other input metadata by themselves. And so by doing that, we're able to provide very natural user interfaces that have freehand gesture, speech, and in some cases intelligent input. But there's a lot of important research directions for the future. So what are the natural commands you want to use when they use speech and gesture? What's the relationship between speech and gesture? When we start speaking, do we issue gesture commands first or second? And how can we recover from errors and so forth? So that's my talk. Here's my contact details and Twitter or website account. And if you go to the show floor, just go on the inside of the door, turn to the left, and we're right there. One last thing I should mention, the other reason why I'm here today is to promote the ISMAR conference. So for those of you who are interested in AR research, if you go to that same booth, you can pick up information about the ISMAR conference, which is the leading AR conference for research, and it's held in Germany this year in September. and I highly recommend all of you go there as well. So thank you very much for the time, and yours.
One thing I thought, Mark, is that if you can get the video working, we'll bring you up right at the end, and you can
I'll
show...
try right now. I think I may have a downloaded copy somewhere else on my computer, but that's really disappointing.
Okay, but we can bring you up if you like after, and if you want to answer a couple of questions after Stanley Yang's talk, you can come back with it.
That would be lovely, and I might be able to download it again, but it's...
Mark calls it ISMA, I call it ISMA. I just realized I pronounced it wrong. So that conference is amazing. I mean, it's really... If you want to have a window into the future where all of this is going, it's a great place to go. So, Mark, do you want to do a couple of questions?
I'm not sure how much. If you've got time, that'll be great. Otherwise,
well, if we still have to set up Roni, so you can do it
sure.
while
That's great.
that. So, let me... You take this.
And Chris has a question right there, it looks like.
Yeah,
Chris, how?
I'm experimenting with multiplayer or interaction between each other with gesture and voice conflicting.
Have I done that? So, so the student that developed, the PhD student that developed the demo on the show floor, that was supposed to be his PhD topic, but it turned out it was too hard to do. Actually, as far as I'm aware, I don't think there's any body who's done a multi-user, multimodal AR system. Maybe Steve Feiner can tell me if I'm wrong, but currently, I mean, we've done certainly many multi-user systems, but I've seen no multi-user, multi-gesture, multi-speech systems working. And partly because of that conflicting problem. But I think it's not too difficult to solve in that you could use things like close-talking microphones, so you wouldn't pick up the speech from everywhere, or microphone arrays, so you could localize the voices. And we do have a system previously that had multiple hands in space, so you could have 2 or 3 people playing together to manipulate virtual balls around, but without the speech part. And you can, if you know where the hands are, you can use things like the 3-gear software to track them back to the body, so you don't... when I start moving an object, it's not going to be attached to your body across the table, for example. So it's technically possible, but as far as I'm aware, nobody's done that yet. So if anybody's in the audience doing a PhD, this is the topic for you.
I think we've got time for one more question, do we? Roni, is Roni ready? Or one more question, right? Good. One more question. I don't see any hands. Yes, there we go.
You mentioned the AI conference. This whole presentation on multimodal interaction didn't include any smart prediction.
Right.
Have you experimented with that, and what can you tell us about that briefly?
So we have done some expert system work, but not for multimodal input. But there's a lot of work being done with that in the traditional 3D user interface and the 2D interface area. So for example, if you give a speech command, you will maybe get 4 or 5 hypotheses of what you've actually said. And then you can use, and when you do a gesture command, you may get several hypotheses as well. So you can use smart inferencing to actually associate the correct gesture with the correct speech. So we haven't done that, but other people have done that for immersive VR and desktop systems. We've been using expert systems for training, and so we've combined AR and AI, I guess, to build smart systems. And the next thing we'll do is actually combine those with, if we get our current government grant money, which we're waiting on, is we'll combine those with multimodal input, so you can use natural interaction to do smart training as well. And we'll definitely be using AI systems for enhancing the command recognition in that case. But there's a lot of work in that area, in the desktop areas in particular.
I hope everyone is going to go and talk to Mark and go and try out what he's working on in his booth. I think we're going to move on now. Yes, you can just... Yeah, thank you.